Thermal energy problems. So the first thing about this is to take a look at your equation. So the equation is actually given, let's back that up there. So the equation is actually right here. Q, which is your change in thermal energy in joules, is equal to mass in kilograms times your change in temperature, which is T final minus T initial, times the specific heat, which is given as C, and that is in joules per kilogram degrees Celsius. Now sometimes this final temperature minus initial temperature, sometimes it's written as delta T. Delta means change change in temperature. Okay, so let's kind of work through the example problem here. So the example problem says, a wooden block has a mass of 20 kilograms and a specific heat of 1700 joules per kilogram Celsius. Find the change in thermal energy of a block as it warms from 15 degrees Celsius to 25 degrees Celsius. So let's take a look at our parts here. So we know our mass is 20 kilograms. We know our change in temperature. So our change in temperature is the final temperature, 25 degrees Celsius, minus the initial temperature, which is 15 degrees Celsius. So our change in temperature is actually 10 degrees Celsius. Okay. And then we know C, we're given C as 1700 joules per kilogram degrees Celsius. Okay. So now our equation, I'm going to kind of rewrite this. Q is equal to M delta T C. And we know M is 20. And we know, by the way, I'm just going to rewrite this over here. So delta T again is that temperature, is T final minus T initial. So I'm just rewriting this delta T. And we already figured out delta T is 10 degrees Celsius. So we'll say 10 degrees Celsius. And then C is 1700 joules per kilogram degrees Celsius. Okay. Now these are on the bottom of the fraction, the kilogram and the degrees Celsius. So that means actually that's going to cancel. That's going to cancel because that's on the bottom of a fraction. So really just multiply this together now. So 20 times 10 times 1700. If you put all that in a calculator, you will end up with 340,000 joules. Now you can actually change this, since this is 1,000, 1,000 equals kilo, right? So 1,000 joules is 1 kilojoule. So we can actually take this, divide it by 1,000, and end up with 340 kilojoules. Okay, so either one of these is a correct answer technically. Now, if you're given different parts of this, Like if we look down here at number 2, it says the temperature of a block, the temperature of a 2 kilogram block increases by 5 degrees Celsius when 2,000 joules of thermal energy are applied. So there, it's asking you to calculate the specific heat, so you're not given C. So we're going to do this with the same numbers we used before. We're not going to work out that problem. I'll let you sort that out. But if you were given 340,000 joules, and you were given the mass of 20, and you were given a change in temperature, say you increase the temperature by 10 degrees Celsius, well, you would end up with this. So you'd end up with 340,000 joules is equal to, and again, if you want to put this up here, Q M delta T C. So mass is 20 kilograms. Change in temperature is still 10 degrees Celsius, but they're asking you to calculate specific heat. So here you just take and divide both sides by the 20 kilograms and the 10 degrees Celsius. Do the same thing over here. Okay, these cancel out over here. So number-wise, what you have is 340,000 divided by 20 and then divided by 10. And what you should end up with, if you do that, is 1,700. And my units, I kind of keep these units of joules per kilogram degrees Celsius. Okay, and that's equal to C. Now you'd be given other parts of this too, but you'd solve it just the same way. So if you were given C, and if you were given your change in temperature and your specific heat, let's do this in a different color. Got a lot of blue going on here. So if you were given your energy, and you were not given the mass, you were given the change in, well, let's see, you were given the change in temperature of 10 degrees Celsius. And you were given 1,700 joules kilogram degrees Celsius. If you were given all that and then asked to solve for mass, well, you could just divide both sides by, this would take care of your 10 degrees Celsius. I'm just doing this all in one big step. You could do this in separate steps if you wanted to. Just divide by the 10 first, then divide by the 1,700. I'm just doing it in one big step, though. So you come over here, you got 10 degrees Celsius on the bottom. And you got 1,700 joules. This is joules too. I forgot to put that in there. Joules kilogram degrees Celsius. Okay. So you divide all this out, and you should come out with, if you put in 340,000 divided by 10, take that answer, divide it by 1,700, you should end up with 20. And that's the mass. Okay, you do the same thing and figure out your temperature change.